Cross, who's working on another JPL project. And our JPL advisors, thank you for coming and thank you for all your support and patience. We will start by greetings from Dr. Emily Allen, our Dean of ECST, and Mike Thornburg.
Hi everyone, I'm Emily Allen, Dean of the College of Engineering, Computer Science and Technology at Cal State LA, and I'm here to welcome you to our virtual Capstone Expo 2020. That's the Expo that's virtual, not the Capstone projects. In fact, our student teams have been working on their projects since our kickoff in August 2019. That seems like a long time ago now, as the COVID-19 pandemic has forced us into physically distant but socially cohesive modes of operation. We have over 100 project presentations to share live with you over Zoom connections. We are very proud of our excellent senior design program, as it rivals programs nationwide in meeting curricular requirements for design. Engineering design is an iterative, creative, problem-solving process in which science, mathematics, and engineering and computing principles are applied to convert resources into solutions. It has a direct and vital impact on the quality of life for all people. With these stakes in mind, our students have been working hard all year long, and especially these past few months, to finish their projects, and these presentations represent the culminating efforts for their degree programs. We deeply appreciate our project sponsors and industry liaisons, our faculty advisors, and the teams that manage and provide instruction for these capstone courses, including Mike Thorburn and Chris Bachman, John Shamma, Howard Lum, Jason Song, and Rupa Purasengi, Paul Liu, Elaine Kang, Jungshu Lim, and Raj Pamula, as well as our staff members, Hasmeek Simon and Evelyn Lee. Now, on with the shows, and I'll see you online.
Hi, everybody. I'm Mike Thorburn, and on behalf of the Cal State University, Los Angeles, and the College of Engineering, Computer Science and Technology, I want to welcome you to the 2020 Engineering, Computer Science and Technology Capstone Senior Design Expo. This year, it's a truly unique experience for us and for you, as the Expo will be done live via Zoom. Additionally, sessions will be recorded for those not able to participate in the live event. The students have all worked especially hard to make this event happen and to ensure the audience is able to participate from a safe social distance. Between mechanical engineering, electrical engineering, computer science, civil engineering, and technology, we have about 100 presentations scheduled over a period of about 2 weeks. I encourage you to participate constructively in as many as you can. Your feedback is critically important to the students. As you're watching this video, you must already know about our webpage. If you take time to go through it, you will find detail about all of the presentations and projects. Cal State LA is protecting the event from mischief by using passwords, but if you request access, we'll happily send it to you. The students have been working on their projects since August of 2019. Obviously, the COVID-19 epidemic was a huge disruption over the last month and a half, and it's been hard for everybody. I'm proud to say our Cal State LA Engineering, Computer Science, and Technology students, just as they have always done, have shown great persistence to overcome the obstacles confronting them and have made a tremendous effort to wrap up their projects and present them to you now. On behalf of the university and on behalf of these terrific students, I welcome you to Expo 2020.
Thank you, Dean Allen and Mike, for those opening words. Once again, welcome to all who are joining today's presentation. My name is Hector Sanchez, and I am the team lead for the MoonTrek telescope application. I am joined here by my fellow group members, Armen, who is responsible for interface development and quality assurance, Rebecca, coordinator of communications and who also assisted interface development, Yi, who worked on the image registration component of our project, and Sebastian, who coordinated our community outreach effort and was responsible for documentation. We are also joined by our previously mentioned faculty advisor, Weronika. Thank you for the feedback and guidance you have given us during this past year. And of course, a big thanks to our project sponsors from NASA JPL, particularly to Sean, Emily, and Natalie, and everyone else who had a part helping us during development. Thank you for your patience and encouragement during these past months. Here is the schedule today's presentation will follow. We will begin with an introduction and overview of the project, followed by project requirements, demonstrations of key functions of the application, and end with closing remarks. So what is the MoonTrek telescope application? First and foremost, it's a community outreach project where the goal is to develop an interface between telescopes and NASA's MoonTrek datasets. This would serve as a tool for amateur astronomers during observation of the moon. And how this would work is that images of the moon visible through the telescope would be processed by the application, which would then send this and any additional input from the user to the database and request and receive information of what is in the telescope's field of view. Here are the technologies used during development. First, we have Vue.js, a JavaScript framework used for building interfaces and which allows for rapid prototyping. 3.js, which allows us to create 3D renderings in web applications. OpenCV Python, which can be used for computer vision applications. And OpenLayers, which is used in applications involving geographical data. I will now pass it on to Sebastian, who will begin discussion of project requirements.
Hi, I'm Sebastian. For our project, we only have two requirements: the ability to connect to a telescope in order to collect coordinates, and the ability to connect to the MoonTrek database in order to get an image. In preparation for the telescope that we were going to receive, we contacted the Physics and Astronomy Club here at Cal State LA in order to get some hands-on experience with setting up and using one. We also coordinated Observe the Moon Night with them in order to, besides working with their community, in order to get test users in preparation for our project. Next slide. This is our DFD0. It shows you how the data is going to be passed along into the application. So it takes in user input from the user, and then it takes the coordinates, and then it passes the from the telescope, and then it passes the coordinates and user input to the MoonTrek database, which will then pass us an image of the moon, which then will be updated to the display. This is our DFD0 1. It shows the interactions more closely. So the user input goes into the user interface module, which is then passed to the communications module, which also receives the coordinates from the telescope. Then it passes the user input and the coordinates to the MoonTrek database, which then passes it the image of the moon, which passes it from the communications module to the interface module, and then it's updated to the display. So the MoonTrek database is one of 9 databases that JPL has, collectively called the Solar System database. It's has all the information that NASA JPL has collected over the years on our solar system. It has a variety of features, or more for the moon, that shows information about the moon. Some of them are the weather on the moon, the iron deposits on the moon, the thermal imaging on the moon, and other various features.
Hi, my name is Rebecca Shen. So our map module is building using JavaScript and library called OpenLayers. OpenLayers is an open source JavaScript library for displaying map data in web browser. It also provides APIs for building rich web-based geographical applications similar to Google Maps. To overcome the lag issue between request and response when using API call with MoonTrek server, we decide to pre-download the data as imagery from the server. Another issue is dealing with large data. Some can be more than 3 GB, in which we decide to solve by using downsample image as layer source. And the map view is configured with a customer projection, which translates image coordinates directly into map coordinates. And as you can see on the side, user can drag and move the map, and there is also option for zoom in and zoom out. Next slide, please. In the map module, there's also a function that displays a pop-up window whenever you click on the map. As you can see in the demo picture on the top, the function takes in map coordinates. It formats the geographical coordinates with the hemisphere, degree, minutes, and seconds. Next slide, please. In the module, the layers are written in order supplied in map component. When user uses add layer function, it will add the given layer to the top of the current map. And for better viewing multiple layers, a couple other functions are developed for user convenience. Layers can be overlaid on the base map and change the opacity for better viewing. On the right top is a demo of how user can change the opacity of a single layer. And on the right bottom, there is a demo of how viewing 3 layers at the same time will look like. Next slide, please.
Hello everyone, my name is Armen. As Rebecca mentioned earlier, the ability to zoom gives the viewer access to see certain geographical features in a very detailed manner. The second phase of overlaying was to create map annotations. Using JavaScript, we were able to annotate certain features of the moon that would be of interest to new users. We wanted annotations to be a way to increase a viewer's curiosity of the moon. It is nice to see a picture of the moon, but by annotating it, we can give a viewer specific as well as neat details. Things we've been able to annotate thus far: craters, rovers, seas of the moon, Apollo missions. But our journey doesn't end here. Unfortunately, due to the coronavirus, we were unable to spend a significant amount of time with our telescope. However, we still have a strong idea where we would like this to go, which is to have integration between map and telescope, as Hector mentioned, that as you view something, it would provide you relevant information of the area of the moon that you're viewing. Next slide, please. After annotating certain geographical areas of the moon, we have provided submenus that contain further information of the areas that are marked. Some of the important things that we would like to display to our users is information such as date of area, location of interest, and some kind of interesting relevant fact such as mission objective, as well as fun facts if available. For example, Apollo 14, when Alan Shepard hit 2 golf balls on the moon. We want each piece of information to be a way to further connect the user's interest so that the telescope community grows to include many more amateurs as well. Next slide, please.
As mentioned by Armen, we want to be able to match the telescope view with a realistic model view of the moon. We can build a 3D render of the moon using 3.js. However, we must ensure that the surface of the moon on screen matches with the telescope view. To do this, we need to know 2 things: the user's position on Earth, labeled here with a red dot and the time at which the user is observing the moon. With this information, it is possible to calculate the closest point on the moon's surface. In this example, we represent this nearest point as a red X. Once we have this nearest point, we can then rotate our camera around our 3D model to render a similar view of what is visible through the telescope. Once this step is done, we may then attempt image registration.
Hi, my name is Yiliang. I'm taking response for the image registrations. I use OpenCV for the image registrations. OpenCV stands for Open Source Computer Vision Library. It's a library of programming functions mainly aimed at real-time computer visions. OpenCV is widely used in many areas, such like facial recognition systems, gesture recognitions, object identifications else. I use ORB features detector to generate the image features. ORB stands for oriented, fast, and rotated brief. The locators used by the ORB detectors is called fast. ORB use modified versions of the features descriptors called brief. ORB is a fast, robust local features detectors that can be used in computer vision tasks like object recognitions or 3D reconstructions. It's based on the fast key points, and the visual descriptor brief is to provide a fast and efficient alternate to a shift. ORB can find features in image and match those features with others' image without worry about lightening, scale, or orientation of the image. Next. So after the 3D models of the moon is generated, I will use it as a reference pictures and a screenshot somewhere on the 2D map of the moon. The matches will let you know where the screenshot is supposed to be located. Next. So here we have an image that from the telescopes on the left side. Because the picture was took by phone, so the picture is blurry. That will more or less affect the results of the matching. Depending on the matches, we will have a rough idea where this image locates in the 3D models. Even it has some bad matches. This means that the approach you use for the registrations that look promising when you are working with the enhanced image does not work for the registers between an enhanced image that taken through the telescopes and the 3D model. Next. So right now I have the image on the phones and try to use the OpenCV to detect it. As I mentioned before, ORB can match features without worry about the lightening, scale, or orientation of the image. So even I rotate the phones, it still can be detected. However, since our applications will need to register an enhanced image taken through the telescopes on Earth, the approach I saw may not work very well for these applications, but we will find a better ways to matching the telescope's image with the 3D model. Next. Here is the example of the image of the register. I rotate the image and take the picture of it at an oblique angles, try to make it different from the reference image. After the ORB find the features in the image and match those features, it can be transformed. The image looks like the reference image. However, these are two same image, but in different angles and shape. We need to test with the telescope. If this function is working well with the telescopes, then it can be useful when the user using their own telescopes to observe the moon. The program can be use the image that user had to request the latitude and longitude of the points on the moon closest to the user locations at that time. Given this coordinate, we generate a 3D model of the moon from the composite image we store locally. We perform registrations between the two images. If this function is not working very well, and then we need to find another algorithms to do the image registrations. Next.
Armen, we can't hear you.
Oh, sorry. There's a few things I'd like to mention that we've accomplished thus far that we're proud of. Open layers used to provide overlays from the MoonTrek database, a step towards image registration, mapping of 2 separate images as Yi just mentioned, building a basic web interface, which is used to provide relevant and important information of certain geographical features of the moon. But I also want to mention our community outreach. By hosting Observe the Moon Night, we've created a testing ground for the future of the telescope MoonTrek application. During this time, we have built strong relationships with the astronomer community on our campus that will help the future of the success of this project. Unfortunately, we were unable to truly experience our telescope, but fortunately, thanks to Weronika and our team, it has been assembled and is ready for the future team that continues this project. The work for the project doesn't stop here. After live telescope implementation, we can provide certain geographic features that is in view of the telescope. Areas of focus would be important locations in the direct view, and as I mentioned earlier, things such as rovers, craters, and Apollo missions. But we also don't want to stop there. Information such as soil composition, temperature, and more of the overlays Rebecca showed you earlier. Next would be further developed to 3D moon so that it could account for sunlight. This way, we can generate realistic shadows and phases of the moon using the 3D model. Thank you. Veronica, you're on mute as well.
Sorry. Thank you, Armen, Yi, Rebecca, Sebastian, and our team lead, Hector. And thank you very much to our sponsors and liaisons from JPL. Shen and Natalie, thank you for your support, and Emily for your leadership. The work that the team this year has done should make it for a relatively smooth sailing for any team that takes over this project, as they have set up the equipment and identified several technical issues that have to be resolved before the telescope MoonTrek application can be used with amateur astronomers to educate and inspire. Thank you very much for attending our presentation.
Okay, can I say something? Hello, this is Elaine.
Yes.
Sure, go ahead.
Okay, so can you unshare the screen first? All right, so thank you for attending the event. Did we receive any comments from attendees? Anybody who wanna talk about the project? Sean, Emily, Natalie?
Hey, this is Sean. I like the way, the direction it's going. The preliminary results look encouraging. It seems like this is something that can actually be done, and I think the next year's class will have a good starting platform to build upon. So I think those are all good things that happened. Unfortunately, we couldn't. We had 2 months of time sucked out of us, so we couldn't quite finish what we wanted to do. But I think it's a good basis for proceeding to the next level.
So I guess I'm already hearing the next year's project.
This is number one.
Okay. So yeah, we can further discuss about topics for the next year after student leaves probably.
Mm-hmm.
Any comment by Emily?
Yes, hi everybody. Well, thank you so much for the really nice presentation. Really well done and very thoughtful. Thanks a lot. certainly, some of the next steps are something that we would definitely would like to do. So looking forward to potentially the next year's project to finishing up. What I really would like is a tighter integration between what you guys have done and our application. So, having your own user interface to do the demonstration is excellent. And in the out years, I really would like to think about how we can actually integrate what has been done into MoonTrek and make it operational through the MoonTrek as well. One thing I would like to add is, Weronika, aren't you, when is your term going to finish?
Oh, so I will work on I will continue to work on the image registration for my thesis through the summer.
Okay. All right. So you will have a thesis done by the end of the summer to share with us.
Yes. Yes.
Okay. All right. That sounds good. And is school pretty much over after this expo, or is there still time to continue some of the work?
2 more weeks. So next week will be the last week, and then after that, final exam week.
Oh, okay. So all the team members will be graduating and after that, then, right? So
yes. So the officially school, the semester ends on May 15 or 16.
Okay, great. Well, congratulations to all of you. Well done. So perhaps some of you guys already have a job lined up for you, and others may be still looking for positions.
Yes, I think so. Some of them probably don't graduate this spring. They may need to take some courses in the summer or fall.
Okay.
But
is any? Go ahead.
I mean, it sounds like are there any job opportunities for our students?
I actually have. I know of a company that actually have opportunities. So I'm going to send it to. I don't know. Do you want me to send it to Yiliang, or do you want me to just forward that information to all the students directly? I guess they can just look at that to see if that is a good opportunity for them or not. The other thing I'd like to ask is any of the students going on to graduate students, the graduate program?
I think Hector.
Rebecca, I know.
Yes, I am.
Might be, yes.
Yes.
Okay. So, if you there's potentially, think about if we have a follow-on project with this, any of you are going to be continuing with the school, might want to continue in the following project as well. Follow-on project.
Sure. Also, I think, Hector, you're in a blended program, right?
No.
You're not? Okay.
No.
All right. Sorry about that. Okay. College asked me to have some screenshot, meaning that if you guys don't mind, can you turn on your video for 10 seconds? And I have a single screenshot showing that, the community for this project. So, Weronika, can you do the screenshot and save the screenshot of this? But if you guys don't mind, please turn on the video for only 10 seconds.
I gotta switch to something that has a camera.
Okay.
Please do, and then I will take screenshots.
I think, Emily, using phone, it's gonna be difficult.
Yeah, and it's I can't turn on the video.
I see.
So,
how about you, George? George is muted. Hi, George. Hi, how are you?
Hello.
Have you ever met the team?
Hector, can we have you?
Sean, I like your beard. That looks
I'm
very
on
cool.
desktop right now. I don't have a webcam on right now. I'm trying to connect through the phone real quick.
I will.
I'm connected
Elaine, I
to
will
the phone as well.
I will take a couple of screenshots, one that just shows faces and the other one that shows everybody who's attending. So bear with me.
Smile.
Say cheese.
Just go online and grab a picture of any kind of.
Hector, can you let me into the meeting?
And my name to it.
And then I can paste. Okay, just a moment.
Armen, you should be admitted.
I guess Armen is connecting.
I have to allow privacy to allow the camera.
Sure, that's fine. Yeah. All right. It's good to see you again, Sean and George. It's been a while, and Natalie too, due to COVID-19. I haven't seen many people. And yesterday I learned from Richard about COVID-15. So I heard that COVID-15 is gaining 15 pounds due to COVID. So these days I can see my Zoom face, my face on Zoom is getting bigger and bigger. I hope you stay safe and healthy. Okay, thanks.
I think we should all just agree to gain 15 pounds, so it's not weird when we come back from this.
Okay, so for fairness, let's just agree. I already achieved the goal.
Okay, let me take another screenshot.
Hey,
just a moment.
Hector, can you thank you.
Okay, great. All right, thank you very much. Hi, Armen. So if Sean and Emily have some time, can I talk to you about next year after or other lead the meeting?
Yeah, absolutely.
Okay. So Weronika, can you stop recording, whoever records, and I invite Weronika, Richard, and Sean and Emily to remain in this meeting room to talk about next year's topic. Natalie too.